Hello! In today's lesson, we will be talking about climate change. At any point during this presentation, you wish to use captions or change the speed of the video, you may do so by pausing the video, then going to the bottom right of your screen where you will see a few symbols. To add captions, click on the box that says CC in blue. To change the video speed, click on the gear symbol that is shown on the bottom left-hand image in orange. Then select playback speed, and then select speed option to change the speed of the video. Values less than 1 will cause the video to go slower. Values greater than 1 will cause the video to become faster in speed. Before we move on to the lesson, think about what your current understanding on climate change is. Have you seen any evidence of climate change? Also, is it caused by anthropogenic activity or by natural processes? Now pause the video and go over to the Think section to answer question number 1, which asks, from what you understand about climate change, is it caused by anthropogenic activity or by natural processes? After you answer the question, you may continue playing the video. Climate change is not a new phenomenon. The Earth's temperature has increased and decreased during the whole of Earth's history. Scientists agree that the climate is changing at a faster rate during our lifetime and that humans are a primary cause for this rapid change through increasing emissions of CO2 and other greenhouse gases to the atmosphere. As a result, the two pictures you see at the top are two images based on data analysis and observations that we are most familiar with climate change. On the upper left-hand corner, you will see the warming of the northern hemisphere, and on the upper right, it is the melting of ice sheets. The change in temperature on Earth can vary due to its response to several factors. One being solar radiation that the Earth receives from the Sun, surface changes on the planet, and atmospheric changes. Scientists have been able to show a correlation between the concentration of greenhouse gases in the atmosphere and temperature changes. It has been agreed that the main cause of observed global temperature changes has been due to an increase in the concentration of greenhouse gases due to the greenhouse gas effect. Here, in this lesson, we will discuss and analyze some of the underlying data that brought the scientific community to this conclusion. The following slide introduces our learning objectives for this lesson. So, 2 learning objectives that you will learn throughout the course of this video will be 1. Being able to describe how the greenhouse effect affects climate change, and being able to explain the 3 factors that control global temperature and their relevance towards temperature changes. So have you ever wondered why does it become colder in the fall and winter months, or why is it very hot in the summer, or why is the Earth not like very cold like Mars or very hot like Venus? It's just the right temperature? Well, it's because there are 3 factors that influence how much energy the Earth receives from the Sun, and how the amount received from the Sun influences its current temperature. These factors include solar variations, which is demonstrated by the first graph towards your left, and this is the amount of energy received by the Sun, and it is determined by how far away the Sun is away from the Earth, daily rotation, and its annual orbits. And these 3 movements are called the Milankovitch cycle. The second graph in the middle demonstrates reflection versus absorption of the Sun's energy. This is also known by the Albedo effect, and this is the energy reflected away from the Earth's surface, and the amount reflected or absorbed varies depending on land use changes such as deforestation that alters forests and other natural ecosystems into cropland or urbanization. In the northeastern United States, the flat soil surface can hold more snow cover in the winter than a forested area, thus increasing albedo and providing a cooling effect on the local area. When the dark soil surface is exposed once again in the warmer months, reflectivity decreases and increases absorption of solar radiation. Lastly, the third control is the amount of energy retained by the Earth's atmosphere. About 71% of energy retained by the Earth's atmosphere is caused by small particles, such as water vapor and dust, that have collected into the atmosphere, absorbing about 23% of incoming solar energy, while the other 48% passes through the atmosphere and is absorbed by the Earth's surface, such as land and the ocean. These are important to be identified, for they are the three ways we can regulate Earth's temperature. Most of the conversation in today's society is focused on greenhouse gases, but there are other examples in helping to maintain Earth's climate. For example, large volcanic eruption emits sulfur and dust particles in the atmosphere, which can reduce the amount of energy reaching their surface and temporarily causing a cooling effect on the local or global regions. Industrial production also emits sulfur particles, which can, to a degree, reduce solar radiation from entering the Earth's surface. We will look further on these three controls in the following slides.
So this slide details the Milankovitch cycle, but before we move on, think about
why does the Earth's orbit or position, such as the tilt of the Earth, lead to the experience of different seasons?
Well, recall that the Milankovitch cycle provides the variation in solar energy that the Earth receives from the Sun due to its daily rotation and its annual orbit. However, the Earth's orbit around the Sun is not the only movement the Earth experiences. The Milankovitch cycle includes three pathways in which these movements occur, and they occur at different timescales. The first position is eccentricity, which changes the shape of the Earth's orbit between circular and elliptical orbit every 100,000 years, and these changes occur due to the Earth's interaction with gravity from other orbits. Second is obliquity, which is the tilt of the Earth or its axial position relative to the Earth's orbit that occurs between 22 and 24.5 degrees on a 41,000-year cycle. And third is precession, which describes whether the northern hemisphere is tilted away from or toward the Sun when the Earth is at its farthest point. It can also be described as a wobble that resembles a spinning top. The Milankovitch cycles are most known for their influence on glacial cycles over the past 500,000 years, and they can affect how much solar radiation reaches the top of the Earth's surface. These glacial periods have occurred on about a 100,000-year cycle due to eccentricity. In addition, the amount of energy received from the Sun also varies depending upon how active the Sun is, which is described in the following slide after the video, which demonstrates the Milankovitch cycle.
So here is an animated video on the Milankovitch cycle. Recall that obliquity is the tilt of the Earth or its axial position relative to the Earth's orbit and rotation, so you can see it spinning at an angle. Eccentricity is the shape of the Earth's orbit or rotation between circular orbit and its elliptical orbit that occurs every 100,000 years or so. And lastly, precession is the wobble that resembles a spinning top. So you can see it spinning at a rotation that is tilted away from or towards the Sun when the Earth is at its farthest point. So the influx of solar variation also includes radiation received from sunspots, which is the reflective magnetic activity of the Sun and the Sun's brightness. And these occur on about an 11-year cycle between the maximum or minimum of solar radiation received from the Sun. Historical records on sunspots has showed that the variations received from these solar activities are connected to climate change, and that one such record has showed that a solar activity during the 17th century was connected to the Little Ice Age that lasted for about a decade. Now pause the video and go over to the Think section to answer question number 2, which asks you to briefly describe 2 reasons why the Earth's orbit impacts the concentration of solar energy that the Earth's surface receives from the sun. After you answer the question, you may continue playing the video. 2 reasons why the Earth's orbit impacts the amount of solar energy that reaches the surface of the Earth is due to 1. The Milankovitch cycle. For the Earth's daily rotation and its annual orbit determines how much overall solar energy the Earth receives at any given point relative to its position from the Sun. 2. Sunspots is the emission of solar energy, and the amount emitted can impact how much solar energy the Earth will receive depending on the position of the Earth from the Sun, such as the northern hemisphere relative to the equator. To understand albedo, first think about wearing a dark versus light t-shirt on a really sunny day. Or think about how fast asphalt heats up in the summer compared to a concrete sidewalk. Which is going to feel warmer, the light or dark t-shirt, or asphalt versus concrete? We know albedo is the amount of light reflected off from the Earth's surface, which helps control the Earth's temperature, and the amount of light reflected or absorbed depends if the surface top is light like snow, ice, and sand, or dark colored like soil surfaces and even forest tree canopies. Now pause the video and go over to the Think section to answer question number 3, which asks, is water a good or poor reflector of solar radiation? How do you think water compares with ice and snow in regard to reflectivity? After you answer the question, you may continue playing the video. Light colors reflect more heat energy and have a higher albedo, like fresh snow and dense clouds, for they can reflect about 85 to 90% of the light falling on them. Aerosols in the atmosphere can lead to a cooling effect because of the energy that is reflected back before reaching Earth. After a large volcanic eruption, the sulfate aerosols in the atmosphere can lead to 1 to 2 years of cooler than normal global air temperatures. The rest is absorbed by the Earth's surface and by water. Surfaces that absorb energy have a low albedo and generally appear dark, like black soil, asphalt pavement, and water, for example, for they have low albedo with reflectivity as low as 3 to 5%. Now, as temperature rises due to the increase in the concentration of greenhouse gases, high albedo material like ice sheets melt, which adds more water and exposes more land surfaces, thus contributing to less reflectivity and more absorption of solar radiation, causing increased warming of the Earth and more ice to melt in regions predominant with snow and ice. However, our climate has a balance of feedbacks between our atmosphere, ocean, and land, which is analogous to temperature regulation of the human body, known as positive and negative feedback loops. Positive feedback can be thought of as an amplifying or accelerated process where the increase in temperature over time causes a warmer planet with drier landscapes. The shift to the absence or minimal presence of vegetation would be a negative feedback loop. For sandy deserts or low vegetated landscapes such as grasslands would increase albedo and more reflected sunlight, leading a cooling effect in the region. It is the balance between these warming and cooling effects which regulate the temperature on Earth.
Now, we will be going over the greenhouse effect, which influences atmospheric temperature. But before we do, draw a diagram demonstrating your current understanding of the greenhouse effect. Please include the following components to your diagram: atmosphere, landmass, greenhouse gases, and direction of solar radiation to and from the Earth's surface. And if possible, please work with a partner and then critique each other's work.
Now that you have drawn a diagram demonstrating your current understanding of the greenhouse effect, let's learn more about how it works in the following slide so you can add any missing information to your diagram.
Here is a simplified diagram showcasing the greenhouse effect, which retains the Earth's energy within the atmosphere, and this attributes to the gradual increase of the Earth's overall temperature, known as global warming. The energy retained by the atmosphere is due to atmospheric composition, which is the third way that the Earth's temperature is influenced. When solar energy passes through the atmosphere, and hit the Earth, some of the heat waves return as long-wave radiation that become trapped within the atmosphere. This is shown by the orange arrows in the diagram. About half of the heat energy is absorbed by the Earth's surface, and the rest is reflected back into space by the gases in the atmosphere and the Earth itself. Some of these gases are better at trapping heat than others, such as water vapor, ozone, carbon dioxide, nitrous oxide, methane, and halocarbons known as CFCs that absorb some of this outgoing radiation. As these gases absorb the infrared radiation from the Earth's surface, they begin to warm up and re-emit infrared radiation, with some of it going out to space and some of it coming back to the surface of the Earth, creating a warming effect. The presence of greenhouse gases in our atmosphere has varied over geologic time and allowed the relatively comfortable temperatures that we experience today. If not for the greenhouse effect, the Earth's temperature will be below freezing, and there will be no liquid water that we can enjoy in today's climate. This concept of the Earth having just the right temperature, not too hot, not too cold, to allow for a habitable climate is known as the Goldilocks zone. However, since the Industrial Revolution, humans have started burning increasingly large amounts of fossil fuels, such as coal, oil, and natural gas, as our population continues to grow and develop. This has led to an increase in greenhouse gas concentrations in the atmosphere, and therefore an enhanced greenhouse gas effect and an overall increase in the warming of the Earth.
Now that we have learned about the greenhouse effect, pause the video and answer question number 4, which asks how does the greenhouse effect make our planet warmer, to test your understanding. After you answer the question, you may continue playing the following video that describes the greenhouse effect in further detail. So lastly, the learning objectives that we are covering in this lesson include 1. Describing how the greenhouse effect affects climate change, and 2. Explain how there are 3 factors that control the Earth's temperature, which includes solar radiation, albedo, and the amount of energy retained by the atmosphere of the Earth. By taking what you have learned from this lesson, please take a moment and reflect on what you have learned about climate change, the relationship between temperature controls and the greenhouse effect, and its effect on a global scale. Now pause the video one last time and go over to the Think section to answer question number 5. After you have answered the question, you can close this video for the lesson has ended. Thank you for watching.